Hello everyone, welcome to Lesson 21, Predictive Modeling. By the end of this lecture, you'll be able to argue for the usefulness of predictive models, calculate the expected time of a task using GoMES and the keystroke level model when provided a use case and KLM time estimates, and calculate the index of difficulty of a pointing task using Fitz's law. Let's talk about predictive models. Remember when we talked about different evaluation techniques? There's this final category, modeling, that we had to revisit, and we're going to do that today. So what can we predict about how a person uses an interface? In other words, what kinds of math equations do you think you could come up with to describe people's actions? Well, this is the realm of predictive models. These provide a way of evaluating products or designs without directly involving users. It is less expensive in terms of time and money than user testing, but it's limited to systems with predictable tasks. For example, telephone answering systems, mobiles, cell phones, etc. And it's often based on expert error-free behavior, so there are some limitations here. Let's talk about two examples, GoMES and KLM. GoMES is, unsurprisingly, an acronym. It stands for the goals, the state that the user wants to achieve, for example, finding a website. Operators, the cognitive processes and physical actions needed, for example, deciding which search engine to use. Methods, procedures for accomplishing the goals, for example, dragging a mouse over the field, typing in keywords, pressing go. And selection rules, methods to select when more than one method is possible. KLM stands for, of course, Dutch Royal Airlines. KLM stands for, of course, Royal Dutch Airlines. But also, it's one example of a GoMES model. GoMES has been developed into a few quantitative models, and one is the keystroke level model, or KLM. This allows predictions to be made about how long it takes an expert user to perform a task. So the way that this would work is you have an operator, a description, and a time in seconds for how long that takes to accomplish. And one operator might be K, which stands for a key, pressing a single key or button. So it depends on your level of expertise. An average skilled typist might take 0.22 seconds to type a key. A non-skilled typist might take 0.28. Pressing a shift or control key is 0.08 because you usually do that coordinating with others. So you kind of hit both similarly at the same time. And a typist unfamiliar with the keyboard might take longer. Other operators might include pointing with a mouse. This is from Fitz's law, which we'll cover shortly. And typically you might expect that to be about 0.4 seconds. And clicking the mouse or a similar device is 0.2. H, another operator, is bringing home hands onto the keyboard or another device. This would be moving from the keyboard to the mouse or from the mouse to the keyboard to kind of switch which one you're using, whether you're going to use the P operators or the K operators. M is mentally prepare or respond, which takes about 1.35 seconds, depending on the task. And the response time is only counted if it causes the user to wait. So this would be the response of the system, which you might be able to measure depending on your system. Let's walk through an example, adding a footer in PowerPoint. You click the Insert tab, you click Header and Footer, you check Footer box, and then you type Slides Adapted from Mark Hancock, as several of these slides are. And then you click Apply to All. So we'll go through this. The first step is to reach for the mouse, which is a home operation, which takes 0.4 seconds. Then you move the pointer to the Insert tab. That's a P or point operation, and that takes 0.4 seconds as well. Then you click on the Insert tab, which is a P1 operation, clicking with the mouse, 0.2 seconds. You move the pointer to header and footer icon, another 0.4. And you click on the header and footer icon, which is another clicking action, this is 0.2. Then you move the pointer to the footer checkbox, another pointing task, and you click on it, another clicking task, a P1 task. And then you move the pointer to the text box and click on the text box. So you have lots of clicking going on. Then we want to type. So you home on the keyboard, that's a home action, another 0.4. The final step is to type Slides Adapted from Mark Hancock, which is 33 keystrokes. So that's 33 times the K operator plus 2 shift operations, which for the capital M and the capital H, which we then factor in separately. So this becomes, assuming a skilled typist, we have 0.22 seconds times 33 Ks plus 0.08 for the 2 different shift keys. And finally, you reach for the mouse, so another homing operation, and you move the pointer to the Apply to All button and then you click apply to all, which is another P1 operation. So you've got an estimate for each of the different steps at the keyboard level. And when you add up all these time estimates, your total is 11.62 seconds. And what you might do is if you have two different versions of the interface, or you want to understand how quickly someone might be able to accomplish this task, you can just run this keystroke level model through your interface and be able to either compare them or get an idea if it meets your requirements that you established earlier on in your project. So now it's your turn. Individually, follow the instructions on Learn to calculate the KLM time for the use case in the handout. Take about 5 minutes for this. Go ahead, I'll wait.